Back with our last video. Woo! 7.3, 7.3. Here we go. I'm going to walk forward. You better move. Huh! Whoa, I got you. Thanks for watching. Okay, let's see here. So you're trying the odds and the evens. You're pushing pause. You're trying each one on your own. Pushing play. See how you did. So remember that we do the powers first. We're going to do the powers first. So we're going to put the 2 in front right there. And that's beautiful. And now we're going to condense our 2 logs, our 2 ln's. So remember that ln is just the same as log base e. So don't freak out. It's the same thing. But just use ln. So ln of, so what does addition become? What does addition become? Multiplication. So we have ln of x squared now. And then addition becomes multiplication of x plus 1. And then we can still go ahead and distribute it through. So distribute the x squared through now. Go ahead and distribute the x squared through. So the x squared times x is going to be ln of x to the 3rd power. And then x squared times 1 is going to be plus x squared. And there's our answer. Woo! So try number 28. I'm going to do 28 because I want you to see a subtraction one. So remember that you take the powers and you put them in front. So that's going to be log, and that's going to be x to the 4th power minus log y to the 4th power. And don't forget that log, if there's no base, you have to assume it's 10, right? So log x is the same as log base 10. So if there is no base, we have to assume that it's base 10. So that's just a base 10. That's just a, oopsie. Yeah, that's just a base 10. But you don't have to write 10. We just assume it's base 10. Okay, cool. So just wanted to point that out. Okay, so what does subtraction become? What does log subtraction become? What does it become? Do you know? So log subtraction becomes log division. So we're going to condense it, log base 10, log base 10. And then it's going to be x to the 4th. And subtraction becomes division. Y to the 4th power. And so that's just our answer. And you could write that with a 4 on the outside if you really wanted to, because they both share it. So if you wanted to put it to the outside, you could, because they both share the 4. But I don't know, I like both answers. Okay, good. Whoa, Newble did it even. Whoa. Okay, use properties of logs, evaluate logarithms. If log x4 equals 0.6627 and log x12 equals approximately 1.879. So they're just giving you these random numbers because they didn't tell us what x even is. That's weird. Maybe they're preparing us for 7.4. I don't know. So yeah, so they give you those 2 numbers and you got to try to get your equation in terms of that number basically. That's crazy, right? That's crazy. Okay, let's see. So for example, we have log base x3. And so I'm thinking, how do you get 3? Maybe like 4. What do you think? Maybe like 4 divided by 12? I don't know. I'm trying to think. Or 12 divided by 4, I'm thinking. Yeah, so I know 12 divided by 4, right? I'm thinking 3. And all they give us is a 12 and a 4. So I'm thinking 12 divided by 4 is 3. That could help us. Huh. Okay, let's give that a try. So maybe this came from something? Man, this is tough. Maybe it came from log base x. Yeah, division, right? Division. So that would be log base x 12, right? Divided by 4, because 12 divided by 4 is 3. So those two equal each other. Cool. Okay. But we need to separate them now, so we need to go ahead and expand it next. And then we can put in those numbers and get an answer. So then we're going to go ahead and do this expands into log base x 12. And then division becomes subtraction. And then log base x 4. Wayo. And so now we can take this number, right, in place of log base x 12. They give us a number. And so that's going to be 1.1879 minus the other number, 0.6627. And so when you go to minus those two, you get 0.5252, I believe. Nice. And we can use our calculator and double check. So 1.1879 minus the 0.6627. Yep, we get 0.5252. So then we're going to, you kind of get the idea. That was a really weird one. Let's get the idea though. So we have log base x 64, but we need it in terms of 4. We need it in terms of 4. So we need to change this base into 4s basically, okay? And so maybe we can make that into 4s. So 64 breaks down into, let's see, 64 breaks down into 8 times 8. And that breaks down into 4 times 2. And this 8 breaks down into 2 times 4. And 2 times 2 is also 4. So 4 times 4 times 4, remember? Triplets. And so 4 times 4 times 4. And so that's basically 4 to the third power. Yeah, we're getting somewhere. So log base x of 4 to the third power. Okay, we got that. Okay, can't we write that with the power like in the front so that we just have log base x4? Yeah, so we're going to take that 3 and just shove it in front now. So that's 3 times log base x4. Wayo! And now we got it in terms of log base 4x. Nice. So now we're going to go ahead and we're going to go in and change. We're going to substitute. We're going to substitute is what we've been doing. So substitute 0.6627. So 3 times 0.6627 is what we're doing there. And so we just plug that into our calculator. So 3 times 0.6627 is 1.9881. Yeah. So that equals 1.9881. Is our answer? Wow, that was a weird section. Let's take a look at our word problems next. And so we have our home mortgage model. T equals 16.625 ln. X over x minus 750, where x is greater than 750, because you don't want 0 on the bottom. T is the length of the mortgage in years, and x is the monthly payment. Use the model to approximate the length to the nearest year of $150,000 mortgage at 6% when the monthly payment is $897.72. So our monthly payment, here we go, monthly payment is in terms of x. So we're saying x equals 897.72. And so basically they want us to approximate the nearest year. And so t is the length in years. So we're just going to plug it in. Easy peasy, lemon squeezy, plug it in. So 16.625 ln of, we're going to plug in for x, 897.72 all over 897.72 minus 750. And we're just going to plug all that into our calculator. Wayo. Carefully. Plug it into your calculator. So we're going to go 16, which is part of our formula, 0.625, minus, not minus, times ln of parentheses. Use lots of parentheses. So times 897.72, close parenthesis, divided by 897.72 minus the 750. Close parenthesis, What did we get? We got 30. We got 30 years is what we're looking at there. So t is equal to 30 years. And then you're going to do the same thing, but this time x equals 1659.24. So go ahead and plug that into your calculator now. And so wherever you see an 897.72, you're going to go ahead and type in a bigger number. Second insert. What is it? 659.24. So minus 750. Again, you're going to do second insert. Second delete. Second insert. 1, right arrow, 659.24. Plug it into your calculator. You should get a number that's between 5 and 15. That's my hint. So go ahead and push enter and tell me what you get. What did you get? T equals how many years? You try. Give it a try. Okay, next it says, approximate the total amounts paid over the term of the mortgage with the given monthly payment and determine how much of the total is interest. Approximate total amounts paid over the term of the mortgage with the given monthly payment and then determine how much of that total is interest. What? This is crazy, right? This is crazy. This is weird. So approximate total amounts paid over the term of the mortgage. I'm going to pause and think about it for a second. Pause me. All right, I think I got it, but it just didn't jump to me very easily because I thought we had to use the formula, but I guess not. So our monthly payment is $897.72 per month, right? We're looking at 30 years, but first we have to turn that monthly payment into year payments. And so we're going to go ahead and times that by 12 months, right? And so then we have, let's see here, awesome. You want me to push enter, don't you? Aha! Okay, so 897.72, good, times 12 months. And so that's per year. So we have 10,772.64, 10,772.64, 10,772.64 per year. And so approximately total amounts paid over the term of the mortgage. Well, it looks like we're looking at the 30-year mortgage first because that's above on part A. And so we're just going to go ahead and times that by 30. And so when you times that by 30, you get a lot of money. 3,203,179.20. Is that right? So times it by 30 years. Times it by 30 years. And so when you times that by 30 years, that's what you get. Okay, well, what's the total interest paid? Well, the total interest is like 6%, right? But I feel like it's compounding, so I'm a little confused here. But we'll see. So what was the initial mortgage? So the initial mortgage, because they give us a formula. Okay, so we borrowed $150,000. This is true. This is crazy sauce. So we borrowed $150,000, and we ended up paying $3,000. We ended up paying $3,223. That's crazy. That's how banks make their money at 6% interest. So we're going to go ahead and minus now the $150,000 that we initially paid. And so we'll do that with our calculator there. So minus $150,000. And so that's how much interest you paid. That's crazy. So that's going to be $179,000. No, $173,179.20. That's crazy sauce. So 173,179.20. So you're trying the same thing now. You try the same thing now. But this one is, so if you pay more payments, it'll take you faster to do it. So it should be less amount of money. So take your 1659.24. times it by 12 months, and then times it by the number of years, whatever that is. So times that by that number right there. Right? And then you'll get that answer, put it here, and then you'll minus your initial 150,000. So go ahead and finish up there. Go ahead and finish up there on, wow, that's a big problem, number 35A and B. I bet that'll be on a test. So maybe we'll see. Okay, cool. 36. What is the value of log base 2 8? So remember to rewrite it. Rewrite it. Set equal to x. So 2 to the x power equals 8. So 2 times 2 is 4 times 2 is 8. I think I might like bananas, and especially the last letter in bananas. Number 37, banana, I mean. John Jones has decided to go into business selling boats. In order to begin this adventure, he must invest $10 million in a boat production plant. The cost to produce each boat will be $7,000, and the selling price will be $20,000. Accounting for cost of the production plant, which of the following expressions represents the profit in dollars that John will realize when X boats are produced and sold? Okay, let's see. Well, you are going to have to minus the initial 10 million for sure, because you have an initial investment of $10 million before you can get that investment, right? Yeah, that's tricky. Let's see. So that's, you must invest 10 million. That's your initial. Is $10 million. Do they give us a rate? No. They just say that's the initial cost is $10 million. The cost to produce each boat will be $7,000. Okay. So we're going to do, oh, but you get the selling price is $20,000. So if you do $20,000 to sell it and minus the cost of $7,000, that'll give us a profit of $13,000. Way-o! And so $13,000 per boat, right? Per boat. But you do have to minus off the 10 million. Way-o! So you do have to minus off the 10 million. So 13,000 per boat minus your initial 10 million will give you the total profits. Woo! Thanks for watching. See you next time on Solving Next Time. These were properties of exponents. Thanks for watching. And bye for now. Bye for now. Thanks for watching. Bye for now.